Deal? Okay. All right, so it starts us back up with basic jump functions. So remember your jump functions that were 1 on the positive side and -1 on the negative side. This is at 1, this is at -1. The parent graph is absolute value of x over x. Or it could be the flip of that. Could be x over the absolute value of x. It would be the same thing. This one is just shifted left 2. So on the parent graph, the hole or the discontinuity is at 0, an x-coordinate of 0. But when you shift it left 2, that discontinuity is just going to shift left 2 to be at -2. So what is your limit as you approach -2? Right? Take this graph. Picture, well, right now the limit at 0 doesn't exist, right? From the right it exists, it's 1. From the left it exists, it's -1. But overall it doesn't exist. So that limit does not exist. But if we shift left 2 units, that jump section is going to be happening at -2. So that limit will not exist at -2. Good? Okay. In number 3, we saw this last chapter. This essentially is going to simplify to, I'm going to cross out that word is just to simplify. It gives us 0 over 0, but it simplifies to x squared over the absolute value of x. Remember, even root of an even degree, put absolute value signs around it. So now when you look at your limit as you approach 0, is it going to make a difference if you're from the right or from the left? I would play around with values. If I was plugging in, let's say, 0.1, so coming at it from the right, I would get 0.01 over 0.1, which is what? How would you do this without a calculator? 1/100th divided by 1/10 maybe. Keep, change, flip. Keep, change, flip. So that would give me 1/10. Pretty small. Another way you could do it, do you remember doing this with decimals? 0.01 divided by 0.1. Do you remember like moving your decimal place over twice to kind of get rid of the decimal and do it in both spots? So it would be 1 over 10 would be your answer. Does that make sense? Okay. So that's if I plug in 0.1. What if I plug in 0.01? Well, then on top, I would have 0.01 squared, which would be even smaller, right? 0.01 squared, that's 1/100th squared, so that's 100 times 100 is 10,000. Tenths, hundredths, thousandths, 1/10,000th over 0.01. So if I moved my decimal place and used that way, I would have to move it 1, 2, 3, 4 times to get rid of that on the numerator, the decimal on the numerator, and then on the bottom I'd have to match moving it 4 times. 1, 2, 3, 4 would make it 1 over 100. So as I progressed from plugging in a 0.1 to plugging in a 0.01, my value went from a 1/10 to a 1/100th. So what do I seem to be approaching as I come from the right? 0. I went from 1/10 to 1/100th. So from the right, 0. Okay? From the left, isn't it going to be the exact same? Because if I square a negative 1/10, it's still going to give me that. And if I absolute value a 1/10, it's still going to give me that. Yes? If I come with a negative 1/100th, when I square it, I'll be at the same number. And when I absolute value it, it's going to be at the same number. Essentially, this is an even function. So whatever's happening on the left is happening on the right, and it's mirrored in the y-axis. So whatever that limit was coming from the right is the same as the limit coming from the left, so the overall limit is 0. That takes more thought. Yes? Okay. Number 5. I'm approaching negative b. What's direct evaluation going to do for me? Probably 0 over 0, huh? Negative b, when I square it, will be b squared. Plus b times negative b will be minus b squared. So b squared minus b squared will be 0. B squared plus b squared, and that'll be my, yeah, so it's going to be 0 over 0. I just always want to check that because I'd hate to do a whole bunch of work and then be like, ugh. And you'll do it. You'll get there because you're so used to direct evaluation not working that you stop trying. And then the one time it would have worked, you've done all this nonsense and you're like, ugh, direct evaluation would have worked. But it doesn't. So I can factor the top and I can factor the bottom. I also could rationalize the bottom, but I don't really want to multiply by that radical if maybe I can avoid it. So on the top I get x plus b when I pull out a GCF. And on the bottom I get the square root of x plus b squared. And so on the bottom, I have a square root of something squared. Even root, even degree. So they don't just cancel. You have to put an absolute value around them. Okay? So if I break this up into two functions and I consider it as x times this x plus b over absolute value of x plus b, the limit as this one approaches negative b is negative b. And then the limit of this one as we approach negative b is what? That's a jump function, right? Something over the absolute value of itself. It is jumping at negative b. And so the limit as you approach negative b does not exist. And so when some part of the limit doesn't exist, and we've seen this in kind of chart-like problems, if you're looking at two functions and you're trying to find the limit of a function times a function, if the limit of one of those functions exists but the other one doesn't, then the whole thing can't exist. So because that does not exist, this one does not exist. Questions? No? Okay. Number 7 is saying the limit of a function as you approach a from the right does not equal the limit of the function as you approach a from the left. Which one could it be? When you approach a from the right, it'll be different than when you approach a from the left. What do you think, Bridget? C, because C is the jump function, and C we know is jumping at A, And so therefore, your limit is different from the left and from the right. We could go through and probably explore the rest of them and see why they do work, but it would be a lengthy process. And really, if you know your jump function, then you know that problem. Okie doke? All right. 9. I'm approaching 0 from the right. So, why from the right? I don't have any idea what this graph looks like. Does the graph exist when x is negative? Yes or no? What do you think, Connor? If I plugged in a negative x value, would it be undefined? All right, let's try. If I plugged in a negative 5, why? What do you think that equals? I'm plugging in negative 5. Yeah, you're right. If I plug in a negative 5, the numerator would be negative 5, but the denominator would be 5 minus 5, which would be 0, which means it doesn't exist in the negatives. That's going to happen for every number in the negatives, right? Okay. So we know now why they're saying just from the right, because the graph doesn't exist to the left of 0. It also doesn't seem to exist right at 0, right? It's probably an open circle. Yes? Because you can't have that denominator be 0. So when you're coming at it from the right, well, let's plug in a 2, and let's plug in a 1. And even though those are whole numbers, we can get closer if we need to. But if I'm coming at it from the right and I plug in a 2, this just equals a half. Yes? If I get even closer and I plug in an x value of 1, this equals a half. Coincidence, or will it always be a half? Ain't it? Why? What would be, looking back, what would be your thought now? So the denominator will always be double. Exactly. Yep. That's not something I would expect you to realize when you first look at it. But after exploration, you're like, and now it makes sense. We look back, why is it always a half? Because really it's x over 2x if you're plugging in a positive x anyway. If you're plugging in a positive x anyway, those absolute value signs mean nothing. So it really is just x over 2x. Your x's cancel. It's a half. So your answer? A half. Okie doke. Okay, 11. Which of the accompanying graphs best represents function f? Take a minute and try this on your own first. All right, let's vote. A is 1, B is 2, C is 3, D is 4, E is 5. And no guess, you're just forfeiting, is holding up a fist. Ready? On your mark, get set, go. Okay, I see. Wait. What'd you have? Okay, good news is, if majority rules, you got it right. Because the majority of you put up a 3, and the answer is C. I saw a couple 2s and a couple 4s, and then I saw a couple people concede. Okay, probably 4, Mrs. Grisanders.
Yes, I don't know. We didn't finish, so we should have a couple more sheets.
Okay. Yeah. So these are the ones you didn't finish?
So like 5 of these, you can keep them together. It's just missing one sheet. I think she put
Oh, okay.
one needs to pencil.
Okay.
All the other ones are done.
Awesome. Thanks,
Thank you.
guys. Thank you. Okay. So, if I'm looking at vertical asymptotes, every single one of these has a vertical asymptote at -1 and 1, right? There's no differentiating. They all have it at -1 and 1. Do we all see why -1 as an x value and +1 as an x value are an issue? Yes? They both make the denominator undefined. So that's the reason for the 2 vertical asymptotes, okay? Horizontal asymptotes are based on the degree rules, right? And this is what we briefly talked about last chapter. The degree of the numerator is what? 1. And the degree of the denominator is 1. So it's same over same, yes? Which means your horizontal asymptote comes from the coefficients, which this has a coefficient of -1, and the denominator has a coefficient of sometimes -1, sometimes +1. Remember how that absolute value kind of created 2 different horizontal asymptotes? So it's 1 over 1, but sometimes it's positive. So for example, if we were going towards positive infinity, the numerator would be a negative number, yes? And if we were going towards a positive infinity, 1 minus a positive infinity would also be a negative number. And that would be a negative over a negative, which would be a +1. Because the same over same is 1 over 1. Yes? So this is if you're going towards a positive infinity. If you are going towards a negative infinity, what happens to your numerator? What's negative infinity? Positive, right? A double negative is a positive. And even if you're plugging in negative infinity, the absolute value is going to nullify that negative sign. So it's still going to be 1 minus infinity, so it's still going to be over a negative. And so the asymptote on the negative infinity side is -1. And that justifies the 2 horizontal asymptotes. Does that make sense? Horizontal asymptotes, having 2 of them is most common when you have an absolute value sign somewhere. Okay? You could argue that with this jump function, that's a same over same, right? 1 over 1. So your horizontal asymptote is at 1, but since you've got an absolute value sign in there, it's actually +1 on one side and -1 on the other side. You could argue, I don't usually think about asymptotes when I look at that because it is just a flat line, but you could argue that that's what's going on there as well. So your homework is, why don't you just finish the packet? Do the evens, plus 13 and 15. So it's a shorter packet than last night, but I think it's a little more challenging, so I think that's appropriate. Just finish the packet.